So we have a body with mass of 1 kg initially at rest. Okay. So first thing first, what is that we need? Yes, before and after diagram. So we have 1 kg initially at rest. So we have an object which is 1 kg. At rest. It explodes and breaks into 3 fragments with a mass in the ratio of 1:1:3. So this is going to be in the ratio of 1:1:3. So this breaks up with 3 parts, 3, 4, 5. I need to divide into 5 equal parts. Pentagon, right? This and this. So yeah, something like this, I guess. So this is part A, B, and this is C, something like this. So 1x, 2x. Actually, I can do the math over here. So guys, this is 5. 5 parts of 1 kg is 1/5 of a kg. And this also will be 1/5 of a kg. And this will be 3/5 of a kg. That's it. Two of the pieces of equal masses fly off perpendicular to each other with a speed of 30 meter per second. Okay, so 2 will fly off, 2 parts. Not a good set of diagram, but perpendicular to each other. Say somewhere over here. This is the point of origin. This is where they originated from. So they fly off in this manner. Okay, so this is with 30 meter per second. 30 meter per second. What is the velocity of the heaviest fragment relative to the lighter ones? Related to the lighter ones. Okay. So the third one will fly off in this manner with a bit lesser velocity though. And it has what speed is the question, and that's it. Okay guys, so this is the question. So we have to figure out x basically. So we can consider this diagram up and left as no, up and right as positive. Let me continue with that. Okay, so what to do? How do we go about? So we can go with the vector form also, or we can go with the conservation of momentum also. Okay, so we can use either of that. So first we'll start off with as per conservation of momentum. The initial momentum should be equal to final momentum. Initial momentum altogether is 0, right? Final momentum is, we have 3 parts, mass A into its velocity A plus mass B into its velocity B plus mass C into velocity C. So till now I didn't bother with this utna because it is all one-dimensional motion, but now we have two-dimensional motion, so we need to take care of this. So everything has to be in vector form. Okay, so this is 0. This is 1/3, 1/5. Yeah, 1/5 of the mass VA. I'll take it as up. So it would be 30 J cap, right? It's 30, right? Yeah, 30 J cap. It's going up, right? So it's 30 J cap. This is 1/5 into 30 I cap going left as per my diagram. And this is 3/5. So this will be VC. So bit of rearrangement, 5, 5, 5, all of this will get cancelled. And we have a bit of rearrangement, VC will be 10 I cap, right, is going to the right and is going down, and 10 j cap. So that is your velocity. What is that we need to figure out? What is the velocity? Right, we have the velocity. As simple as that. If they want magnitude, how do you figure out the magnitude? Root of 2 root of 10 meter per second. Then I hope I'm not doing, no, it's right. Then we have, what else do we have? Oh, this is, my bad, 10 root 2. Then what else do we need? Direction. So that's your magnitude. Next we have the direction. So this would be tan theta is equal to 10 by 10, that is 1. So theta is equal to 45 degree. But since we are talking about which quadrant? This is fourth quadrant in our diagram. As we are in fourth quadrant, this will be 45 degree. This is clockwise from positive x-axis. Or yeah, I mean with this can be the reference, or the one which is going to the left, or one which is going up. With respect to that, it is 135 degree. So however you guys want to write it, you can write that. Then what else do we need? Oh yeah, so this is velocity of the part C with in general with respect to the ground, but with respect to other things, you know, this or this, what is the velocity? That too we have to figure out. So next we have, oh, I don't have space actually, velocity of C with respect to A, I guess. So how will we figure this out? This will be velocity of C minus velocity of A. So this I'll do the math directly. C is 10 and A is what? A is to the left, 30 meter per second. So 10 I cap minus 10 j cap, minus of minus, that will be plus 30 I cap. This will be 40 I cap minus 10 j cap. So VAC in terms of magnitude will be, how much will that be? Square root of 1700, 41.23. Okay, so 41.23 meter per second. Okay, so that is the magnitude with which this will fly off with respect to this. That is, if I consider this as stationary, how fast is this going is the question. So that is your answer though. Okay, so you can pause, have a look.